Welcome to another episode of the value. Oh, it's not the value engineering experts. It's the contractor innovation podcast. We're
Yeah,
getting going. We're doing a weekly, Matt. So every
we're
every
good.
week, every week we're going to be spot on. Dante is producer and familiar with podcasts, and that's what he
Mhm.
does.
Yeah.
So it works out well. Anyway, Matt, I've known you a long time. I was looking at writing a few notes here. I'm going on 43, be 44 years of experience. And you weren't far behind me when you came
No,
aboard
I think,
Deep
yeah, I'm about
Foundation.
38.
Yeah. Why don't you tell the audience um, a little bit about yourself in terms of what you've done over the last 38 years that tied us in?
Sure. Well, I started in dewatering, um, and that was a brief stint with a contractor, but it was a very, very beneficial. I mean, as a geotechnical engineer, if there wasn't water in the ground, I wouldn't have a job. And I think most geotechs would agree with that. From there, I went back, finished my master's degree in Foundation and Structural Dynamics with Milos Novak at the University of Western Ontario. So that was a frequency-based dynamics program, which I found very beneficial. And then I had a brief stint with Deep Foundations with you, Martin. You were operations manager, and I was just a young green engineer figuring out how to drill holes in the ground, and that was hugely beneficial. And I was introduced, by Bill Lardner in the Deep organization to low strain and high strain dynamic analysis. So sonic integrity testing and pile driving analysis and that sort of thing. And then I went back to finish my master's and ended up getting a phone call from Patrick Birmingham at Birminghammer Corp and Birmingham Construction in Hamilton asking if I wanted to light rockets on piles and find out how strong they were. And that was just too much fun to, pass up. So I spent 10 years developing Statnamic load testing with Patrick and the Dutch group TNO out of IBBC. And that was wonderful learning about electronics before a lot of the stuff that's just taken for granted today even existed. Analog to digital processing was in its infancy. You couldn't just go out and buy the stuff, and getting multiple channels that had the processing frequency that we wanted was a real challenge. And today, it's nothing that you can get that at a local electronics store. So a really great introduction to foundations, loading, and dynamics. And it was very interesting because we designed pile driving hammers as well and other equipment. And everybody was running around using high strain dynamic analysis, PDA, to find out how strong the pile was. Well, we looked at that and said, wow, this is going to tell me how hard my hammer's hitting. This is going to tell me if my hammer's hitting plumb or not. This is going to tell me how much energy I'm delivering through my hammer and my drive system into the pile. So we used it as a pile hammer design tool. And through that came up with the first diesel direct drive hammers that had no cushioning, and then developed the first smokeless diesel hammers that could be used in California and offshore and some great stuff. And then from there, I went on and joined Isherwood Associates and as a design consultant on excavation support with Nader Ansari, our colleague. I was at school with Nader, and while with Birminghammer, I would get pulled over to the construction side when they had interesting jobs or jobs that needed, something different, or even when they were just too busy and needed another set of somewhat able hands out in the field. And so I'd worked with Nader a fair bit, and then went on and joined him and built the Shepherd subways. Did a lot of finite element analysis and design for the Shepherd subway system, and then just continued on with them doing some really interesting projects. Of course, a couple with you, Martin. Highlights would include um, the Bow and Canna structure in Calgary, which was a hugely innovative system that you know, spearheaded and developed and were the mastermind behind. We were just all the guys crunching the numbers. So that, you know, hats off to you on that one. And then you came into Vancouver and did the Surrey Memorial Hospital. And that too was a very successful project and one that I was just on the line with a PCL Ellis Don joint venture building a hospital in Ottawa, talking about some of the innovations there that we're going to bring over to the Ottawa project. So, you know, big circle, all comes around and around. And I've had a really fortunate, varied career from geotechnical design, contracting, manufacturing. So a lot of innovation. So a lot of fun.
Yeah, very good. Good summary, Matt. How's things at Isherwood? You're mainly doing Isherwood work in Vancouver?
I am. I am developing a new device, but you know, I can't stop doing that. It's a disease. But yeah, I'm working with the Isherwood. We have an office of about 10 in Vancouver, and doing a lot of work on the Eglinton subway system and the new Scarborough line. And then, you know, a lot of the major structures in Toronto and a few across the West. So again, on excavation, supportive excavation design side. And then I guess I didn't talk about my past with developing high frequency drills and hammers. Um, I developed with an Australian fellow a high frequency system that could run at 150 hertz and resonate piles and drills. And through that, got very interested in sonic drilling and investigation. And I'm developing now a sonic wireline core barrel mechanism. Very difficult to connect to a sonically driven pipe because the frequencies and accelerations are so high, it tends to weld, you know, friction weld any connection that you try to make. And I've got a system that I'm developing and patenting now that will be able to do that.
So you have a few patents, which is interesting. As you know, I created some patents since I left ACM, and
Hmm.
I'm actually going to sell them. I've been talking to some of the big players like Keller, and it looks promising. So
Good.
the it's interesting how so many things get done, but talking about that, I have a question right away about your your fusion welding. Would you would you actually weld something to drive it, or you're trying to get away
Oh
without
no.
that?
Yeah, we're trying to prevent that. The friction welding is a brilliant system in order to deliberately connect uh, pieces of steel, and in particular, friction welding is used very commonly to weld nipples onto drill pipe. So the nipples are the ends. They're machined. They've got special features, and then the length of drill pipe in between is just a chunk of pipe. Well, it's a chunk of very high quality steel pipe, but the nipples where all the money is, and so they need to weld those. They do the machining and processing and heat treating, et cetera, on the nipples, and then weld them to the pipe. And friction welding is a very, very good method to do that. And
So
friction welding
that's like
is
high speed, like a high
yeah,
speed, where
yeah.
you don't actually have rod, uh,
No.
but you're putting a permanent almost bond, right? Because of
Well, it's a pure full weld. So what one does is put a flux on the ends of the pipe, which is it prevents impurities from entering into the system. You spin the nipple or the pipe to very, very high RPM, and then you press on one piece to the other in a very high force, with a very high force. And then the friction that's created superheats that steel and melts it and welds it together.
is
So
it
it's a true weld.
is it friction from rotation, or is it
Yes.
friction? Yeah. So
In that application.
you have a patent for that, Matt? Good for
No,
you.
no, no. That's a very common system that's used. What I want to do, I want to take a tool, send it down a drill pipe, connect it down at the tip of the drill pipe, and then they want to sonically excite that. Well, nobody can make that connection. The typical wireline connections use, a mechanical lever type connection, and it just cannot take the loads that are present during sonic drilling where the accelerations are so high, and thus the forces are very high. So you need to go down there and make a very, very high force connection. And the technology isn't available to do that. And so what I'm developing is a connection mechanism that can be connected and released and brought back to surface so that you can connect, sonically advance the core to get 10 feet of core, then disconnect and bring it back up on a cable. Right now, they have to run drill steels the whole way down and the whole way out every time they want to get a soil sample.
So do you have it solved, or you're more in an R&D phase? Sounds it's challenging.
R&D phase, but we like what we have. We've built a prototype.
And you have a partner in that?
No.
No, just yourself.
Yes. I've got partners to go and do the field testing. One of the local drilling companies is very interested in doing this. It'll revolutionize soil investigation and sonic drilling. Basically cutting the time in half or less to go and get core samples out of the ground.
How's our friends at Horizon? I think it was Troy, wasn't it?
Troy, he left Horizon. Horizon is no longer. Horizon with Karen and Karim and their team. Troy split off, created Terrain Engineering. So he's in a small geotechnical outfit called Terrain that he runs. And then Karen and her team were recently purchased by a larger engineering group. And so I think I can't recall the name just offhand. I'll get that for you. But they've done that usual sort of growth and then and changed ownership.
So also in your background, which you didn't mention for the benefit of our audience, you were 3 years Deep Foundations Institute president.
Oh, yeah.
Yeah.
Yep, served with the Deep Foundation Institute as a trustee and eventually on the executive committee. Yep. Thank you.
Was that pretty well a full-time job, or was it
No.
No,
That's very much a volunteer position, supported by Isherwood, and well, there is a staff at DFI, but the trustees and the directors are all volunteers and supported by their individual corporations.
What would you say is Isherwood's most interesting job right now? Because you obviously get involved in anything Nader does, I would think he's going to
we do.
you.
Well, the senior people there, Carol Dimitrick, myself, and Nader, we generally see all the really interesting ones. And of course, interest means risk. We're doing some interesting stuff. We're going out into the middle of the Peace River and building a cofferdam that's got to go through the winter, which is going to be very interesting ice loading and that sort of thing there. We've got some very deep excavations that are ongoing. We've got some large elliptical shafts with large breakthroughs in them so that, if you've got a compression shaft, it relies on the compression being equal all the way around. And then we're going to cut out half the shaft through the process. So, that becomes quite interesting how to engineer around that. I'd like to say that the subway work is very interesting, but I'm afraid I find it very bureaucratic, very paper laden.
A lot of overdesign, is there not? Don't they?
Ton of overdesign, a ton of restriction on the freedoms that we would like to have in design. It's a pretty frustrating process.
Is that from the P3 owners typically? They're structural engineers, or
there's a combination.
It's
There's
not
a
a,
combination of things.
so I remember this issue. It seemed more like the more people spent on hard costs, the more they could get as a percentage of billing. This is on a prime consultant. This is my skeptical. I couldn't understand some of the over designs that go on, particularly with the actual subway walls. They say that, well, some of them are shotcrete, but they say that, it's going to be a nuclear retreat. Is that some of the issues that people are facing, Matt? I was always not a,
It's
yeah.
it's a big part of it. A very good paper was recently written by Natter, Shauna Munn of Isherwood at that time, and Alison Bennett at that time. And I would encourage it was published in the DFI, and it's called Prescriptive Specification Design: The Impact on Cost and Constructability, a Case History. And prescriptive specification design is a very interesting problem. And that is that, they consult experts on subway construction and write a project agreement or similar document that says, thou shalt, design in this manner, meet this specification, et cetera, et cetera. And they're very poorly informed. We have specifications and requirements being imposed upon us that are absolutely inappropriate and force us to spend an incredible amount of money to meet them. And so, as an example,
You mean capital cost money or more cost analysis?
both.
Yeah.
And of course, we're 4 to 5% of the cost of the structure. Bumping me up by 30, 40% doesn't do much, but bump construction up by 30, 40, 50, 60%, that costs a lot of money. And as an example, we're excavating 25-meter deep holes in Toronto tills, which are excellent soil and perform very, very well. And a very typical movement, acceptable movement for a wall is about 0.5%, right, of H. So if you take 0.5% of a 25-meter deep excavation, you get 50 millimeters. No problem for that wall to move 50 millimeters, right? And it's prescribed to us that it must move no more than 25. And there's penalties if it goes beyond 25. So we are being told to design to and assure that the movements would be less than 25 millimeters. So we're designing for movements of 15, 16 millimeters instead of 50 millimeters. And that costs money. That absolutely, the only thing it does is cost money and result in overdesign. And what's even more frustrating here is they haven't, on the Eglinton line, the next expansion to the Eglinton line that is under construction now, they haven't got a permanent designer in place. So they don't know what they're putting in the hole, in the excavation, and yet we've started. So we are building a hole that's 300 millimeters wider and longer than the subway station that they're going to install because they want some room in case they, need to change things. So we're being held to less than 25 millimeters of movement, and they've got 150 millimeters of gap on each wall between the excavation support and the future structure.
You're kidding.
What's the point?
Who's the
We're
general?
just spending money. They don't know where the slabs are. And they're prescribing to us that as we build out, we don't exceed the 25 millimeters.
Now, so you have to prove it with calculations.
Calculations, finite element analysis, and then, Martin, this is what kills me. These foreign engineers who don't build in glaciated till soils tell us that the soil parameters we're using are inappropriate. We've got a 25-year history of full-scale models, case histories, modeling. The TTC knows and trusts what we're doing, and yet the TTC is not consulted. They're not considered capable of building subways. They built the Shepherd Line, and on, extensions to the Young, extensions to, Vaughan, et cetera, et cetera. And they're not listening to us in terms of the soil parameters that we can point to structures within a stone's throw of the excavations that we're building, and yet the soil parameters we're suggesting are considered inappropriate.
Even though you can back calculate movements and prove that
We got data,
yeah.
And the geotechnical investigation that was conducted, there was a few different groups, in particular WSP, Golder. Um, you know, Golder does a good geotechnical investigation. They give them a lot of money and they do a very good job. They put money in the ground and they know what to do. They do good tests and they get good data. A very workable document that we rarely have the benefit of actually using when we're building things. They've got good information, and yet we're really handcuffed in how we use and interpret that information because of the project agreements and contractual responsibilities and specifications that are being thrust upon us that are inappropriate.
So Matthew, that's it doesn't sound like a lot's changed. I couldn't really work in that environment. It'd be too difficult for me being an innovator and
It is difficult.
I worry about concrete and steel from a sustainability standpoint and don't like to waste it, i.e. the bow design. Dante I was going to ask your opinion of FEH2O lock, which is one of the patents I'm going to sell to our world's biggest contractor. I'll probably work a couple more years, Matt, and just go work for them. Because I can't get out of it completely. It's in your blood. How old are you now, by the way?
I'm 64.
Wow.
I know it's scary, isn't it?
I'm 66. But anyway, Dante, can you bring up in any particular order? I gave you 5 slides of FEH2O lock. This is the system that has the rear drainage, Matt. I think you're.
Yeah, I'm very familiar. Yeah,
Yeah.
We've talked about these many times.
So I just wanted to revisit that in light of. Have you heard of Chem Concrete, by the way?
Only through your correspondence.
Yeah, so we can show one of the slides is basically it's a game changer. It's affordable, and I'm not directly involved, but I would specify it to replace barrier waterproofing with shotcrete. So now this is you might remember the FEH2O lock system where we would put 2 5-inch layers of shotcrete on, Matt.
Mm-hmm.
And then I came up with that spigoted connection. I've done this before on a single bypass and at HCM. But then I thought, well, if I put a double layer on and drain it, I can get what I would call a water management system. I mean, the truth of the tills in Toronto is that they're all dry. If you have fill, I think right now the constraint, tell me probably more accurately, they make you put an artificial water table in the job for the fill, right? So that drives it into a bathtub situation with 2,400 kilograms per cubic meter of rebar. So you must be into those 2,400 kilogram per cubic meter of rebar dense permanent structure walls, correct?
Well, we don't get involved in the design of the bathtub walls. Of course, we're giving them the hole into which to put them. So I can't speak very intelligently towards those walls. But yeah, the city of Toronto and many major, cities are in a huge problem with the limited infrastructure that they have, and yet people want to keep building. And we've got this historical structures that, bring all kinds of storm water from the ground into the structure and pump it into the storm system. And that was all grandfathered in. But when new structures are required to have zero output into the storm sewer. And, again, the cities and municipalities are in a horrible situation of limited capacity. But zero is the wrong number because, if you tell them that they got to be 99% less water, they can do that at a reasonable and efficient cost. But when you tell them zero, you add orders of magnitude to the costs of completing a structure. And so that's a real issue. But, I don't want to leave you with that and say that the cities are making a mistake. They don't have more capacity. So it's a really tough problem. And so systems like yours that stop the water are extremely valuable to the construction community at this time.
So one thing I would do, by the way, is I would use Isherwood, and it might be a chance for you and I to work together again, but I would use Isherwood for design because Isherwood has historically such a good credibility with the city of Toronto, which
Mhm.
I think most things are led by the city of Toronto and other cities follow. Put the next slide on, Dante.
Yeah, the
We
city
got
of Toronto's does a great job in their engineering department. They're well run. They got big problems that they manage well. Um, we know the people there, and they don't like imposing a zero groundwater infiltration and removal, bylaw more than anybody else. Their hands are tied.
so yeah, okay. This one is fine. I can talk about this one. Can you get it a little bigger? So
Yeah.
it's interesting that how I got the patent, but basically this is a wood float finish, double layer of 5-inch shotcrete that's a bypass. You might remember I welded tabs on the flange of the pile, which actually gives it a composite action, but we don't really design for that. We would like always your comments on it, but
Well, that just
go
as a
ahead.
pause, that's a big area of research for us right now. The composite action is is poorly understood, has a major contribution to system stiffness and strength, and is not being utilized. And the
On a
problem is that
seat count wall, for instance, right?
there's no code that covers low strength concretes, et cetera. So we've got to develop that. And what you're talking about, yeah, you're going to use full strength concrete on the face, but the steel behind and the concrete behind is low strength. And so there's a real battle to incorporate that into the design with a recognized, mathematical system or the physics behind it.
Even though Isherwood would probably stamp what they believe in, you've got to get it by the structural guy, correct?
Oh,
Go
we
ahead.
can't. Yeah, you need to have a basis for what you're designing upon in your analysis, and so we need to do the work to create that basis.
This system would be very stiff because it truly is a composite action beam. The fact that I would go with 5 MPa on the pile fill so I could trim it properly. And then I would weld those tabs. They were 2x2 by quarter tabs, maybe 3-inch square. And it's a number of competitors have copied that system. And I think HCM just doesn't do it because of their trying to make it easy or whatever. Who knows why
Well,
they would do secant walls? To me, the bypass system, this system in particular, this is patented. So can you show Dante the next picture? I want to show
Mhm.
something more from plan view.
Martin,
Oh,
I got to
there it
tell
is.
you,
Yeah.
I've copied your bypass tab system. I don't know how many times. It's a fantastic design and innovation.
Yeah. So this is the water management system. And recognizing that we're in tills, we get rid of the secant wall and we have that bypass system. The, so then, but you have to put this 450 mirror drain board on. Now, Natter always said the rate of evaporation exceeds the rate of leakage in Toronto. So this would put this to the point where the water would have to flow down that drain board full depth. And I'm saying in 9 out of 10 sites, there'd be no water left at the bottom. So there would be no water going into the storm system. Now, you might be familiar with the fact that I have a geothermal. It's probably my best patent. I think it'll make the sale go to Keller. We can put in 20-ton, 30-ton FE BTU cells, and we evaporate water instead of glycol. So we get tremendous air conditioning and very good for hot climates. You know, Keller has 45 offices in the States and five in Canada, I think. Apparently Keller's going to move their head office to Canada. And
Really?
I would probably move towards, it would probably be Edmonton, wouldn't you think? If they move to, it's a guess, but I don't know for sure. But I was told that their head office for North America is going to be in Canada. And, you know, they're the world's biggest geotechnical contractor, so they certainly have the money. But that's the concept. That's the drain board, and the composite action is no doubt there. Plus, it's arguably there from the friction of the shotcrete. So I'm putting a wood float finish on it, and I would get 2,000 pounds a square foot bond at least, maybe more, and a very high composite action.
When you talk about the 2,000 pounds a square foot bond, are you talking, what are you talking about? Are you referring to the shotcrete to the soldier pile or between the shotcrete faces?
Between the shotcrete faces. You know,
how do you establish that?
Well, you could design pull-off tests, but can you imagine if you were to put, let's say, a frame together and try and jack a layer off? I mean, concrete to concrete in a wood float finish format is extremely high bond. I mean, we're probably go ahead.
If I can interrupt, and I'm sorry to do that, Martin, but
no, do it.
Extremely important that you say it's a wood float finish, because if you, I think I'm preaching to the man who really understands shotcrete, but if you just run shotcrete, the overspray from the adjacent shotcreting operations creates a poor layer of concrete over top of the shotcrete and makes it a very poor cold joint bond. But if you wood float it after it's shot, you eliminate that. You work it into the concrete. You don't have that overspray, and you've got a very good concrete surface. So I'd be very interested in that, in the wood float finish and the information around that.
You know, to do that, we'd have to do something similar to the bowl, and I'm a big believer in QA. So we'd have to have it watched. But can you put another slide on? Because I think we have one that shows what's called the feather edge. The feather edge.
I've seen the feather edge. Yep.
Yeah. So
I think that's it for the ones you sent me. You sent me one picture, Martin.
Yeah.
If you go back a couple of slides, the feather edge is shown in section. Not that one, the next one, the one you showed after that, where it's a double layer.
Yeah, that one there.
Yeah, go back right there.
That one there.
So that shows the feather edge.
Yeah, so they're staggered and they're all wood float. So you end up, even from an inspection standpoint, you could even say to somebody, well, I want that pressure washed, you know, if there was mud, site work and whatnot. But the idea is a staggered feather joint, wood float finish, and staggered joints. And you get the composite action. I believe you could get away with, you know, substituting, what are they, 24 at 68? You could probably get an 18 at 55 in there with a composite action. You'd be tremendously powerful. We never had any movement on bypass jobs. And it's very fast, Matt, because you don't have the secants. We can separate the piles 6 to 10 feet. If the till was good, this system would work well with.
And are you suggesting that this is the final basement wall?
Well,
Or
I've
just the shoring?
my partner in Seas Chuckreed is William Chen, and I think you'd probably be into a situation where you couldn't get away. I could do it with string lines, but you've got to satisfy a structural engineer for the final wall. But we would shoot the final wall. If you got crews on site, you would definitely shoot the final walls, the same way a Verde does it, or Consolidated Shotcrete. Houston's got 10 crews going with.
Yeah, it's falling out of favor up here. And I think what's happened is that the good quality people that make sure that they do a good job of a shotcrete basement wall are getting undercut by the less quality conscious contractors, and as a result there's a poorer product out there and the clients aren't happy with it. So they're really throwing the baby out with the bathwater, in that they're not satisfied with the product, but they're hiring the cheapest people. So I think it was a good system, but again, the bar has been lowered to the point where it's no longer a good system.
I think what happened was the lack of QC and the fact that they have interruptions at floor levels. So this would have no interruption at your floor level, because you're literally 60 feet high with a wall like this. And then as you come down, I would put a final wall on, but to tell you the truth, I think I could offer a 15-year waterproof warranty, because with a bit of bonding, you come and fix it yourself anyway. So,
Martin, sorry to cut you off. We just have 1 minute left on this recording.
Okay, well, Matt, we'll do another one time. We're keeping it quick, and we do one every week. But
Look forward to that.
You were great. Thanks a lot as a guest. It's always interesting.
Mhm.
People will watch your podcast for sure. They all like Matt Janes. Anyway,
Martin, thanks. Great seeing you again. All the best. Have a good weekend. Thank you, Dante.
No
Okay,
problem.
bud.
Have a good one. Thank you for joining us.
Keep that system in mind, eh? Okay.
I will. Absolutely. Thanks. Okay. Good day.
Baby, I need to know.